Hello everyone, this is Shatrupa and welcome to Campusmonk. So today we'll be looking into a little difficult kind of a question. Not that difficult if you actually understand the question, but yeah, you have to do a lot of code over here. I'm not claiming that I have the best code that I'll show it up to you today, but definitely it's an optimized one. You can run that in big OFN. But if you guys have a better solution, do drop it in the comment section or let us know, okay? So we'll start with the question. It says that you are given certain kind of thing. Okay, so it's basically a tree question. Okay, now tree question usually gets complicated when you don't understand the tree structure. So we'll try to understand the tree structure first. It says that you're given a tree of n nodes. Okay, each node has a value of a of I written on it. Okay, at each the tree is rooted at node 1. Okay, fair enough. Now a pair of nodes I and j where 1 less than equal to I less than j and less than equal to n is considered good if a of I and a of j is a perfect square. Okay, so how will you bring down to that? Perfect square basically means if you multiply two numbers that has the same kind of number, it is a perfect square, right? Like 2 into 2, 3 into 3, 4 into 4, they're all perfect squares. Okay, so we define beauty u as the number of good pairs of nodes in the subtree of u. Your task is to find the beauty of I for each, whatever the constraint is. Return the sum of the values. Okay, so basically, this is your main part. You can ignore this because if you're considering writing an online assessment, then you can pretty well do this in this much of modulo time. Okay, so this is not 109, it is basically 10 to the power of 9. Okay, so just ignore that. So now you have been given few function definition. Okay, so you have to basically write few function that they have already defined for you and you have to use the exact same name. Okay, one is the get answer, that will have parameter n, that is the size of the tree, that will have par, basically the parent array, and integer a, the value written on the nodes. Okay, so you have to complete this function. But will that be all? I don't think so. We'll need to have few more things. Okay, so what are those few more things? So what will you return? You'll basically return a single integer. Why? Because you're finding the sum, right? So sum is just an integer. So these are the list of constraints that has been given. Again, this is 10 to the power of 9. Okay, so you have been given these all constraint, which is fine, and this is again 10 to the power of 9. Okay, so yeah, I'm just seeing the question for the first time. So you have your input, that line number 1 is the n number of integers that you're going to put in, that is the size of the tree. Then next n lines will be your parent at 0 1 till whatever you have. Okay, so parent at 0 is typically 0 because you are giving the root reference. Okay, it already mentions the indicator, you're not giving the value. Okay, once you're done with that, you will put in next n lines as the values. Now it is the values. Okay, so your output must be a single integer, right? Now this is your input and your output is also given. So how do you know that this is the input? Okay, let's consider. So it said this one was the size, right? So if it is 5, then next 5, 1, 2, 3, 4, and 5, these are the root indicators, so we can ignore them. Now this is the value that actually is the part of the tree. Okay, so we'll consider that. So at the first level you're having 2. How do I know that? Because the 0 is the root, right? That is what was mentioned in the part over here. So typically it is 0, okay, indicated as 0. Then you have two ones, that means it has two nodes. What are they respectively? They are 3 and 6, right? Then they have 2, 2, right? Now, which one will have 2, 2? Since it's going to be forming like this will be your 12, this will be your 27. Okay, like this. So this is your tree structure, basic tree structure. Okay, we are already given that if value of I times value of j, okay, if that is a perfect square, then it is a good pair. Okay, if it is a perfect square, then it is a good pair. Okay, but how do you want how will you calculate the beauty of u? It is basically the number of good pairs inside the subtree u, correct? Now let's number this. These are the values, right? Now let's put this up as 1, 2, 3, 4, 5. Why? Because these will act as a u. Okay, that beauty at u that you will calculate, you can basically say beauty at 1, beauty at 2. It will become easier instead of using the values. Okay, so I'm going to remove this. So what will be the next step? The next step will be that we convert each of these value to a square free core. Means we remove all the prime factors with even power. Okay, and only keep the prime factors with odd number of power, okay, whatever the thing is. So now what is your first one? It is 2, right? So for 2, what will it be? What will be our core? So it is not a perfect square, right? So it is basically going to be 2 only. Similarly, okay, let's do one more thing before we hop onto this. Let me tell you, we are going to use a DFS. Why will we use a DFS? Because we are given a tree, right? So we'll travel all the way to the bottom. We'll start over here and then travel back to the root, okay? So that is why we'll be using a DFS. BFS will not work that well because we have to calculate. If you see, then these two nodes are dependent on this one, okay? So BFS won't give us a correct answer, but if you want, you can definitely try it. I'm not stopping you. Probably it will be a little more time consuming to just have an appropriate code. So we'll start at the bottom level, that is 12. Now if I want to make this square free and find out the core, right, then what will I do? How can I write 12? I can write 12 as think about it. So I can write it as 4 times 3, which can be written as 2 to the power 2 into 3 to the power 1. Okay, so what is the core of 12? Core of 12 is 3. We are not going to consider the ones with the even power, okay? So what is the core of 12? We'll put it down here. Core of 12 is 3, right? Similarly, what is the next one? Is 27, right? So what is the core of 27? So 27 can be written as 3q, right? So which is equal to 3. We are just taking that number, okay, that power. So 27 will also be 3. Next, what do we have? We have 3, right? So 3 is just equal to 3, right? You don't have to do anything. So what will be the core? Core of 3 will be 3. Next, what do you have? You have 6, okay? It's like you'll do left, right, parent, then again left, right, and parent, right? That is what a DFS is. So now for 6, what will it be? It will basically be 2 into 3. Now both of them has power of 1, so you will consider both. So that will be 6, right? So 6 will be 6. And what do you have at the top? You have 2, right? So what is 2? 2 is nothing but 1 into 2. So 1 into 2 is always 2. So it doesn't matter. So you will just put this up as 2 is 2, right? Now we will rewrite the tree with the codes instead of the values. So what will we do? So this was the original tree. Okay, if you want, we can just redraw another tree instead of destroying that one. So what will we do? We'll just change that. So what is the core of 2? It is 2. What is the core of 3? That is 3. What is the core of 6? It is 6. What is the core of 12? It is 3. What is the core of 27? That is also 3. Okay. So this is our new tree that we will work with. So this is 6. I don't know what happened to this 6. Okay. So this is 6. Now we are going to basically do, what did we do? We did DFS, right? So if it is a DFS, now we need to store the count in order to figure out if it is a good pair or not. So for that, we'll be using a map. Okay. Now, since it's a DFS, we'll start at the bottom. Okay. So if I have to calculate at node 4, like this beauty of 4, okay, beauty of 4, then what will I do? What is the core value? Your core is equal to 3, the one that we have here, right? So what will this map hold? Map will hold the core as the key. And what is the frequency? It has occurred once, right? That will be the value. Similarly, if I do for say beauty at 5, okay, beauty at 5, core has occurred how many times? What is the core? 3, right? It has occurred one time. So you will write this like this, okay? Now if you do your core, so your beauty at 2, what is the beauty at 2? What's the core value? It's 3 again, right? But what is happening along with this? You're merging this and this, right? So what will your map at 2 look like? Initially, just for 2, your map is like this, okay? So this is for beauty at 4, this is for beauty at 5, this is for beauty at 6, okay? But what is your map looking like? So it is going to merge these two values. So what will you do? You will increment all the numbers over here. So ultimately your map will have the value of 3 times 3. Okay. So your 3, the code 3 has occurred 3 times in this subtree. Okay. You will only merge when you find a parent of the subtree. Okay. So we'll get rid of all of this and just store the last map that we have at 2. That is, so beauty at 2 is equal to 3 times 3. Okay, beauty at 4 was 3, 1, and beauty at 5 was 3, 1. Okay, I hope you have understood this, right? So once this is done, what are you going to do? Next is you're complete with this left side. So you go to the right side. Right side is this, right? So what is your beauty at 3? Your beauty at 3, you just have the core of 6 and that has occurred once, right? So that's it. Okay, nothing else. Now what are you evaluating? You're going to evaluate for the actual parent node, right? That is beauty at 1. Now what is your beauty at 1? What's the core value? It is 2, and that will be this. So if I actually merge all of these together, if I merge all of these together over here, if I merge all of these together, what will be my value? What will it store? It will store the value of this one and this one, right? So what will my map over here look like? My map at B of 1 will look like, it will have its own, definitely. It will have for this, that is 3 times 3 right here, and it will have for this, that is this, right? 6 times 1. Okay. So technically, this is the whole thing that you have deduced. Now, why didn't we store this? Because if this is a child node of 2, that means 4 and 5 value has already been considered by 2. So we don't have to store it over here. Okay. So now, if you actually see one thing, let's see one thing. So if you see this one, this, okay, your beauty at 1, okay, equal to your beauty at 2, which is equal to 3. Okay. Why did I say so? How many occurrences are you getting? 1, 2, and 3. Correct. And similarly, here also, this has occurred 3 times. Correct. So your beauty, here also it has 3 times. Here also it is 3 times. So your beauty of 1 and your beauty of 2 is equal to 3, right? Which is a good pair. So that means how will you finally calculate your beauty? So you will have something like this. So suppose this is the node. This is the beauty. This is at node 1, 2, 3, 4, and 5. So at 1 it will be 3, 2 it will be 3, rest all it will be 0. Why will it be 0? Because you're basically not finding any matching core. Okay. Rest of them does not have any matching core. Correct. There are no matching core in root here because it is 6, 1. At 4 it is 3, 1. Not a matching core. At 5 no matching core, right? But at B2 there is a 3, and at B1 also there is a 3. So they are a matching core. And what is the core value that is matching? 3, 3. Okay. So what will you find? You will finally find the sum. So what will be the sum of all of this? It will be 3 plus 3 plus 0 plus 0 plus 0, that is equal to 6. So if you go up your output, it is 6. Okay. All right. So if we basically do a further more in-depth analysis and you try to understand. So at fourth node, what was your map? It was this, right? At your fifth node, your map was this, right? At 2, you merged 4 and 5 with 2. So your map became this due to the merge. Okay. At 3, your map is this. Correct. And at 1, your map due to the merge, it is what? It is merge of all of them. This was the itself value of 1. Then you have 2's value. And then you have 3's value. Right. Now, how many good pairs did you find inside the tree? We found one at 4 comma 5. Correct. We found one at 2 comma 5. We found one at 2 comma 4, right? So these were the good pairs inside the subtree. Got it? So there were 3, and that is why you got your value as 3 over here. Okay. And this one is same because of the 3, 3. Okay. So what is your total when you write down the beauty? What did you do? You just made sure that you write the corresponding value. Whenever there is a matching pair, you will use that value. Okay. So what was the matching pair? It was 3. Okay. All right. So I know it was a pretty lengthy explanation. So we are going to jump straight into the code. So it's going to be a pretty lengthy code. If you have an easier or better code, I don't mind. Use that. Go ahead. Okay. So suppose the first thing that I'm going to do is, since I'm coding this in Colab, I'm just going to make sure my system doesn't crash. I will do this as set recursion limit to say, I'll put it as maybe 300,000. Okay. That's it. And your mod is already given to you. So what is your mod value that has been given to you? It has been given to you 10 to the power of 9 plus 7, right? So you do that. Now, we are going to do a simple thing, that is we are going to figure out the square free codes. So, oops, I'm sorry. We'll do def and we'll call square free core, okay, and we'll pass a x, okay, any number. Now we'll set our result to equal to 1, and let's set our I to equal to 2, okay. Now what will be your condition that this loop will run till? It will be I times I, right? It will be I times I, and it should be less than equal to your x only till that time, because it's a perfect square, okay. Now your count, let's assign that to 0. Once you assign your count to 0, say while. Now you're doing the actual calculation for figuring out that it is not you're for figuring out the core, okay. Mod I, which is equal to 0. If this is the condition, it's going to do I integer division. Basically your x will be equal to x integer division by I, okay. And your count will do an XOR operation on I, okay. Now what are we going to figure out is pretty interesting. Next will be, you will basically compare if your count is equal to 1. If that's the case, then your result will be basically nothing but result into I, okay. This will be your output, and then what will you do? You are going to basically increment the value of I by 1, okay, because you will go to the next one. Now if your x is greater than 1, okay, if that's the case, then simply do one thing, that your result is equal to result into x, okay, and you will return your result. This is the first part, okay, of finding out the core. Got it? What is the next thing? Next thing is the definition or the function that we were given in the question, that was get your answer, okay. Now that had three parameters. One was n, one was the parent, and other one was the a, right? So if you don't remember, recommend going back and referring back to the question. Now let's define the tree. How will you define the tree? So tree is nothing but your list of lists. But when will you create this list? You'll run a loop in the range of n plus 1, okay. Now within this, you're going to run another loop, say I, in the range. What will be the range? It will be 2 comma n plus 1, okay. It's starting from the next node. Now what are you going to do at every tree? You're going to append, but what will you append? You will append the value of the parent, okay, whatever it is at par of I. Dot append where? What? Append what? You're appending the value, so that will be basically I, okay. Now we'll need to create an empty array or a list, whatever you want to call. We'll name that core, but it will be initialized with all zeros in the start times what? Whatever the size is. So that will be n plus 1. Okay. Now for I in the range of again 1 to n plus 1. Okay. If this is the thing, then your core of I is equal to, what are you going to call? You're going to call the function that you defined on the top, that is square free core a of I. Okay. So you're going to define this. Now you are finally going to call something as beauty. Beauty is basically you're calculating the value. Now before that, you need to make an array or a list, and again this will be same as the size of your core, right? If core is also initialized for n plus 1, your beauty also has to be initialized for n plus 1, right? Now once you are done with this, what are you going to do? You're going to define your DFS. Now DFS of what? Of beauty. So let's call that u, because that is what was given in the code, question. Now let's call this as my map, okay, and we will make this a map, right? But what will it have? It will basically have core of u that will initially have the value of 1. Okay, we'll do this. Now we'll run that for child in tree. Okay, for every child node, you will have a child map. Now what will this child map hold? It will basically be the DFS of the child node. Okay. Now, what are you going to do? The next part will be that beauty of u. Now you have to increment this value, right? Because if you have found 1, but increment it with what? You will increment this value with beauty of child. Okay? Because this is the parent node, so you have to increment it with the beauty of child. Got it? Now, once you are done with this, what is the next thing that you must do? You must do is to do the merging. Okay? So you have to merge the child node into the parent node, correct? So how will you merge your child node into the parent node? You'll do a comparison for that. So if the length of your child map, that's the child map, right? Yep. If the child map is greater than the length of my map, okay? Okay. So if that is the case, then what are you going to do? You're going to do my map and child map, and then you're just going to swap those two things, correct? Now, the next thing that you have online is to count the perfect square pair. So how will you do that? So for K and V, like the key value pair in your where in your child map dot items, okay, and you call that as a function. In that, you're going to check if your key is in your map. If the key is already in your map, then what are you going to do? You're just going to increment that value, right? You're going to increment that value, correct? Now, once you have incremented that value, what will be your next step? It will be the else part, correct? So if you have incremented this value, then you will actually no, I guess I missed a chunk of this. So if this is your map, so you are going to do basically my map. So for K in V, so this. Yeah, so you're not going to calculate the map part, right? You need the beauty part. I'm sorry, guys. This code is little big. It's huge, so it's just going to mess up my mind for some time. So it's going to do my map at K, and then we'll have times V. Okay, and there's no else part here. We're just going to remove this. Okay. Now, for the same thing, what are we going to do? We are going to do another uh, loop where we are going to now merge. Okay, where we are basically going to merge. So we'll run for K and V in their child map again. Okay, this is going to be for the merge. Previous one was for counting the perfect square pairs. This one is for the merging the frequency. Okay, items. Now what are you going to do? Now this will be my map of K, that will be equal to my map. You need to get the value first. Okay, so you will get the value dot get K comma 0 plus your V. Okay, now at the end, what are you going to do? You're going to return, basically you will return your, I just hope I'm just maintaining that same path. Return my map. Okay, now we are done with this piece of your code as well. Okay, so once this is done, what are you going to do now? You are going to come out of this, and what will you call? You will call your DFS on your main node, right? And then you will return, what will you return? You will return the sum of beauty. Okay, but we'll do one thing. We will basically do mod of mod. I guess I've chosen that as mod as well. Yep. Okay, so that will be mod. Now why is this an error? Are we outside the function? Oh yeah. And this one has to be inside. Perfect. Okay. So once you're done with this, next what you have is your main function. Okay. So you will do if, we'll just use this, and okay, we are not going to directly use this. I don't know. But since this is going to be basically an user input, so make sure you use strip function. Okay. And once this is done, say you'll take input for your parent node. So how will you take it? It's going to be as this, n plus 1. Okay. And you're going to run this loop for how much? For till that n plus 1. So you will start for I in range 1 comma n plus 1. Okay. And what will be your input for this? So here you have already taken the input. What will you do? You're basically uh, processing this. So you will do it something like this. Okay. So this will be input dot. Okay. So you have it here, and then you will have your same thing for A. Okay. So you took input for N. For P, for A, you will also take it in the same range, and then you're going to just print your answer. Correct? So if we run this, let's enter 5. Okay. And we'll enter the exact same numbers that we had. So that was probably 0, 1, 1, then 2, 2. And now we have to enter our value for the tree. So that was 2, 3, 6, then 12, then 27. So your output, okay, why did it throw none? So let's just debug. Did we put it in something wrong? Okay, so I'm not sure. So we are just going to rerun this. I think everything is fine. So it will be 0, then you have 1, then you have 1 again, then 2, then probably 2 again, then you have 2. Now these are the values that you're entering: 3, then 6, then 12, then 27. Right? So, yep, you got the answer. Okay, I'm not sure what went wrong at that time. I just refreshed my screen and it started working. So, all you need to do is to be patient while you write this code, because I am extremely tired by writing this code. It's a pretty lengthy one. So, this is in Python. So, we'll shortly see it in Java as well. Okay. So for Java, if you see, so this is the primary interface. I'm not going to rewrite the whole code again. It's going to be pretty lengthy. So if you see, this is going to basically import your java.util and input output standard files. This is your main. I'm using an online compiler. So if you want, you can use your own. Okay. So I've set this mod to a very large number. We're going to take list, which will make our tree, and we have our beauty, and we will calculate the core, right? So the internal function of computing the square free core still remains the same. Okay. So here I've added all your indentation and everything, so it's easy for you to understand this code. So you're doing the same thing. Your result is 1 and your I is 2, and you're iterating till the time this is less than equal to x, because I and I is a perfect square. Okay. So your count is 0. It's the same code that you will write and return the result. The difference here will be in how you store the hash map, because it's not just two curly braces like it is in Python, but rather you have to create this. So how will you do? You will create a function, okay, hash map, and you will pass two things, that is one for the key, one for the value, right? And you will name that function as DFS. And what are you parsing? You're parsing u, the beauty factor, okay? So now you're going to create this hash map, and this is how you create it. Okay. You name it as my map, and you call the new thing that will create a hash map for you. All right. And this will be your input to the hash map initially. Okay. Like how we stored it as 3 is to 1, right? In Python. So here it will store it with a comma without a colon. Okay. Now you're just going to iterate for every child. You will figure out the beauty, and you're going to just append it. So you're going to just add the child's beauty to the parent's beauty. Okay. And similarly, you're going to swap. If the child map is larger, then you have to just swap the maps. Okay. And you have to count the good pair like we did earlier. Okay. That what are the good pair that you have, and you're just going to sum them up. Okay. Now, what is the important part is the merge. Okay. You gotta merge all of these together. Like you merged for tree node 4 and 5. For the tree node 4 and 5 over here, you merged it with 2, correct? So similarly, you're going to do this for everything. This is your main function. That is the get answer that you were already asked to use. So that was having n, par as in the parent, and then a as the value. Okay. So you're going to create list of all of those for the tree, beauty, and the core. And then you will create a new array list for the tree, and you start appending the values of the parent node of I into the tree. Okay. And what will your core of I have? Basically the square free values, the core that we just calculated. Okay. And then you're just going to return the sum. Okay. You're going to do the sum and return it. And the main function is similar. Just take a scanner class as an input, okay, for n for your number of things, your par as in whatever you want to parse in as the parent node, okay, and a as in the value, okay, and finally call the get answer on this. So let's just run this, and I'm going to increase the height over here. So say we'll enter 5, then 0, 1, 1, 2, 2. So these are all the nodes, okay, all the parent nodes. Now we are going to enter the value, that is a. So it is 2, 3, 6, 12, 27. Okay, there you go. You have 6 as your output. All right. So yeah, I'm not going to rewrite the whole code. It is too big to rewrite it, but you definitely have it here on the screen. You may pause the video and take a screenshot. All right. Before concluding, I would just talk about the time complexity. So what is your time complexity? Your time complexity is basically big O of n. Okay. And your space complexity is also big O of n. Okay. So I'm going to copy this. And so we go back to our Python script. So we'll put it up here as well. So this will just change to your hash. Okay. So your space and time complexity are both big O of n. All right. Because we are going to store everything. We are storing the map. We are storing the tree structure. Basically, map is the tree structure. So yeah, we are storing that. So that is why you're going to have a big O of n. All right. So it's a very straightforward question. It's not that difficult, but the kind of explanation they have provided, the kind of question they have given, makes it look like, oh my God, this cannot be evaluated. Okay. So it says the question is basically good sequence with GCD problem. Okay. So you are given an array A of length n and an integer p. A non-empty subsequence of A is considered good if it has the following condition, that length of that subsequence should be strictly less than n. Definitely. Okay. The greatest common divisor GCD of the elements of the subsequence is exactly P. Two things. That suppose that subsequence is B, that should be less than n, that is size of your A. Second, the GCD of B should be equal to the value of P. Okay, it should be equal. Now you have to process query queues. Okay, in the following form. After each query, you must check if there exists any good subsequence or not. If it exists, then answer is yes. If not, then it's okay. You don't have to do anything. What you have to return is find the number of queries that were answered yes. So total you have to find out. Okay. So what are you going to do? Basically, how will you take in the query in the form ij? That means just separated by space. Say 1, 2, ij. That means replace a of I. This one is the index. Okay. A of 1 should be replaced with 2. Okay. Should be equal to 2. Okay. It is not a of j. Okay. It is just 2, the value 2. Okay. Now let's see how will you take the function description. So you basically have to write this function. Okay. And there will be an integer array n, okay, which is the size. Then you'll have A, that will have the elements of the array. P, that is the required GCD. Q are the number of queries that you will enter and check if even after changing those values, like even after changing A of I is equal to J, even after doing this number and GCD of remaining array elements or the subarray elements still equals to the given P. Okay, if that is satisfying or not, if that is working out or not. Okay, and then you have queries, that is integer 2D, and each query is in the format of this. Okay, like 1 space 2, that means this is the index A of 1, while this one is the value that will be assigned to this. Okay, and finally your output will just be an integer, that will be the number of queries that were answered yes, the number of queries that were finally being seen. Even after changing these, even after executing these queries, the GCD was still equivalent to the initial P that was given. Okay, so these are the constraints. Now we look into something very interesting here, that is the input format. Okay, so it says first n, that is the number of element or size of the array. Okay, so that will be your first line. So your first line will be size of array. Next, n lines, that means whatever the size of the array is, basically the elements of the array. Okay, that is next lines will be what is the element, the elements. Okay, next n plus 2, that means after this you will have your p, which will be equal to whatever your p value is. Okay, then you will have your q, that will be the number of query. So this is your required GCD, this is your query, number of queries. Okay. Then in next one, you will just have a constant thing that is probably, let's call it call or column. So that will always be 2. Okay. So you'll always have two columns, that is I and J. Okay. That will be A of I is equal to J. So these will just be 2, 1 and 2. So that value will always be 2. Okay. But I don't know why it is asking us to take that as an input. This is the interesting part. Okay. Often we miss out on this. So do not miss out on this. This should go in as your input and this will always be 2. Okay. Because if you miss this, then you're going to make a big mess and none of your answers will match. Okay. So this is important. It will always be 2. Remember that. Next is the next Q lines will basically be the queries, like whatever your I, J value will be. Okay. Say 1, 3, 2, 6, like that way. Okay. So each line of this query will contain two space separated integers like this. So like this, okay, 1 and 3. They are separated by an empty space. 2 and 6 separated by an empty space, okay. So this is the, 1 is the indexed position in the array and J is the new value to replace that given value, okay. And your output will be a single integer definitely because it is the number of queries that matched, right? Now, let's look into this sample test case, okay. So if you remember, this is your n, correct? Now, this test case, when they have provided it slightly different, okay? And I only realized when I started executing it. So I don't blame you if you really don't get your answer correct in the first go, okay? What did the input format tell us? Input format told us that first is N, then it's A, all the elements, okay? And then P. But when they have given the sample test case, it has been given as N. Then this is the P. This is your A of 1, A of 2, A of 3, and A of 4. Okay. Why A of 4? Because there are 4 elements, so definitely it will be A of 4. Okay. Now this one is your Q. Okay. And this one should not be 3. This is an error. This should be 2. Okay. This is basically your columns. Okay. That is always 2. Now these are your query 1, query 2, and query 3. Okay. So you wrote your 3 queries. So you have 3 queries here. Okay. And this is the number of columns. Okay. So they messed up while giving the input and that is why your output is 3. Okay. So we'll see that how it happens. But in the explanation, they have clarified this, which is a good thing. Okay. So like you see in the input, they mentioned that A is basically going to be right after N. But if you go down to the explanation, they have mentioned it that your N here is 4. That is the first. Perfect. But the next one is not the element. It is the P. Okay. Then the next 4 items, that is 9, 12, 15, and 18 is basically your array. This is your array A. Okay. And then your Q is 3, this one. And then that should be your call because that has been written over here, that integer 2, and it is always 2. So it was written here as 3, which is a mistake. So it has to be 2. Okay. You can try it with 3. It will give you an error. You won't get the desired output. Okay. And then these are the queries. Okay. 1, 9, 2, 6, 4, 12. These are the 3 queries that will be entered. Right. So let's understand this explanation. It says your n is equal to 4. This is your p, that means this is your required GCD. And this is your a, this is your query. Now, if we execute the first thing, okay, first you need to calculate is your GCD. Now, you know that all the elements 9, 12, 15, and 18, they are divisible by 3, okay. Now, initially, what was your C? Your C is equal to 4, okay. I am not sure why they have mentioned C, but I pretty much think that that is not C. That is your N. Okay. But anyways, that does not matter anymore. Okay. So once you have calculated the initial GCD, that 3 is the GCD which makes everything divisible. So then you will directly go to your query. So your first query in the input, if you see, it is 1 and 9. So your first query is 1 and 9. Now what does this 1 and 9 mean? So it means A at 1 has to be changed to the value of 9. Okay. So now this was your given array. This was your A of 1, then 2, then 3, and then 4, right? Here the array is not starting with 0. It is starting with 1, 2, 3, and 4. Okay. So your A at 1 is 9 and you change it to 9. So no change. That is what it says. 9 will be changed to 9. No change. So it is still divisible by 3 and your array is this. And your GCD is still 3. So now this GCD after executing the query is 3 and your P is also 3, right? So your GCD is equal to your P. Correct? So this answer. So here your this query will contribute to the answer, okay, because you need to find the number of queries. So this one is 1, your count is 1. Next, over here your query is a of 2 should be assigned to 6, right? So what is your a of 2? Your a was 9, 12, 15 and 18, correct? So your a of 2 is this, so this 12 will be changed to 6. Now it will become 9, 6, 15 and 18, correct? So this is your new array, 9, 6, 15 and 18. Again, if you find the GCD, that will still be 3, right? Because 3 can divide 9, 6, 15 and 18, all of them, correct? So this one will also be another query that will be contributing to the solution. Why? Because your GCD is 3 and your P, that is the required GCD, that is also 3. So they both are equal, okay? Now the last one is a of 4 has to be changed to 12. That means 18 will change to 12. So what will be your new array? It will be 9, 6, 15 and 12, right? So this will be your new array. Still all of them are divisible by 3. So your GCD is still 3. Now GCD is still equal to your given P, correct? So this will also contribute to your answer. So your total yes is 3. Got it? So and that is your output that was mentioned over here, right? Similarly, we have few more examples to look through. So this is your N, okay? This is your P. This is your A of 1. This is your A of 2, right? Now you have two element as one, so these are your two array elements, okay? Now this is your Q, this is your column, and this is your query 1, this is your query 2, and if you try solving it, you will get the output of 2, okay? Similarly, this is your N is equal to 3, this is your P, okay? So this is your A of 0, A of 1, sorry, A of 1, A of 2, and A of 3, okay? So these three are your array elements. Since your N is 3, so you have 3 array elements. Got it? Now again, your this is Q, this is your columns. This is your Q1, query 1, query 2, and query 3. So if you execute all of this, you will just have one yes. Alright? So now we'll see how we can code this. I hope you have understood the logic. So what are you doing is first you will calculate the initial GCD, okay, of the initial given array, the original array, and then if your it is divisible, it is equal to your P, you will execute query 1, okay, and query 2 and query 3, and amongst all of them you will see, or whatever number of query is given, you will compare the GCD after changing the array. Is it still equal to the given P? If yes, that will contribute towards making a answer, okay? So we will code this in two languages. First, we'll code this properly in Java, and then I have the Python code ready for you. So I'll just go through it and we'll just understand how you are doing it in Python. Okay. So for Java, I am going to use an online compiler, but if you have your own IDE, please use that. Okay. So we'll do first import java.util, right? The default thing. So we'll have java.util, and we'll also have import java.io. Okay, we'll import this as well. Now, since I'm using a GCD, okay, sorry, not GCD, GBD, an online compiler. So definitely this has its own class, and that is called as the main. So if you are using your own IDE, please feel free to name your class whatever you want to name it. Okay. So now the first thing that we will write down is to compute your GCD. So what will we write? Say public static, and this will return something. So we'll do it as an int GCD. And what will we have for comparing the GCD? We'll have int A and int B, correct? Now within this, how do you calculate a GCD? So I'm going to directly write the logic. So it's B not equal to 0. Okay, if this is the condition, then your int, let's take a temporary variable temp, is equal to B. Okay, why we are taking this? Because I don't want to lose the value of B. Okay, then B should be equal to A mod B. Let me give some space so it's clear. Okay, and A is finally equal to your temp. Okay, that's all that you need to do. And finally, what will you return? You are returning your A. Okay, you will return your A. That's it. Now you are already done with GCD. Now the next function that you need to write is the one that was asked to write in the exam. Okay, and what was that? That was this one, get answer. If we just scroll up, it says this one. You need to complete this get answer, and these are the parameters that it should have. Okay, these are all the parameters that it should technically have. So let's just code this part now. So we are done with this, and I will leave another space, and we'll say we call this public static. What do you want to call this? Int get answers. Okay, how was that written? I just want to cross verify. Okay, get answer, and we'll take some input that is n. Then you will have your integer array a, and you will have your int p. You will have your int q, correct? And you will have your uh, I mean, you will have your int q as well, right? Sorry, column as well. So we will consider that also. So say we will take in as int call, okay? And so we will not consider say call because it's always going to be 2, right? It's going to be constant always. So we'll just let it be. And we will consider the queries, okay? And in that, okay, you cannot scroll up the screen any further. Okay, no problem. So I hope you can see the screen still. So we'll do an int count. This will keep track of how many queries said a yes. Okay. Now you are going to run this for loop. How will you run? Say int k is equal to 0. Okay. And k is less than q. You know what your q is, okay? The number of queries. And then you will do a q plus plus. And we are going to write the actual query part now. Okay. So this is basically going to be your I and your j. So your I will be equal to, what will it be? It will be your queries k and 0 minus 1. Why? Because you're basically converting this into a index, okay? Because this is an index, it is not a value. Next will be your j, that is a value. So it will be queries of k at 1. Okay, and how is that assigned? I of a of I is equal to your j. Okay, just the value. Now, once you are done with this, you're going to check for the good sequence. So you will take a list, okay, and say that is of integer type. And what are we going to name this? Say we'll check if it is divisible or not. So we'll do it, just call that divisible. Okay, and that will be equal to a new array list. Okay, and how do you write it? You write it like this, correct? So once this part is done, now you are going to run another loop, say for in of x colon a. Now what are you basically doing? You are now going to check if this is actually divisible, okay? So this is how you write the divisible thing. So it will be if your x mod p, okay, is equal to 0. Then what will you do? Divisible dot add x, okay? This is what you are going to do. Got it? And once you're out of this, you will check if your divisible is empty. Okay, if that is empty, then just continue. Don't have to do anything, simply continue. Okay, the next thing will basically be if you are going to create those new things that you're going to append and then put that into a hash set. So we are going to use a lot of data structures over here. You've already seen using array list. Now we'll use set or hash set, whatever you want to call that. Okay, so that will be again an integer. Let's call it say possible GCDs. Okay, and let's say this will be equal to your hash set. Okay, and what will you pass through this? You will pass divisible. Okay, so once this is done, now you are again going to run this loop, say for, and what will you do? You will do int num to divisible. If that is true, then you are doing one thing, that is your set of integer. Okay, like basically the set that you have created, you will create another one calling that to be the new GCDs, and that will be an empty list, okay, or an empty set. So that will be new hash set, and it will be empty. Okay, Now, what are you going to do? You're going to basically keep adding the new GCD or new possibility of the GCD that you will have. So, say for int G, two possible GCDs. What will you do? You will do new GCDs dot add all new GCDs. Okay. Now, once this is done, it is not just this much. What are you going to do? You just did that. Okay. Why did I just combine it? So we'll first do new GC dot add. Then what are you going to add? You're going to add GCD num, comma, whatever the new value is. Okay. Now, once this is done, outside this, you're going to add all possible GCDs, right? So you will call that possible GCDs. Do add all on new GCDs. Okay. This is what you will do. Okay. Sorry for the previous one. That was my mistake. Okay. So once you are done with this loop, you just come out, and what are you going to check? That if your possible GCD contains P, if that contains P, that is your required GCD. If that is the case, then initially we had initialized a count, just increment that. Okay. Now you are done with this for loop, the main one. You just come out of this, and what are you going to do? You will return count. Okay. That's it. Now after this is your main function that you wrote. Okay, the get answer thing. Now once this is done, what are you going to start writing? You will do it for the public static void main. Okay, and here I'm just going to add one thing because I'm not sure how this editor will react, so I'm just going to add one extra thing, that is throws IO exception. Okay, IO exception, and that's it. Okay, so now what are you going to write within this? Okay, so we will basically do it in buffered reader. If you want, you can do scanner class as well. Okay, so we'll say buffered reader, say br is equal to new buffered reader. Okay, and what are we going to send in that? You'll basically have new input stream reader. Okay, and you will basically have system dot in. Got it? So once this part is done, you are done with your you have opened the gateway to take inputs, right? Now we'll start with our inputs. The first one was input n. So this is basically the number of array elements that you have. So we are going to keep this in mind, that we will not write any kind of sentence while taking an input in an online assessment. Okay, so you do parse int br dot read line. Okay, next what do you have? You basically have your what was it given in the input format? Where's the input format? Okay, the next one was a, correct? So we'll take a. So it will be int a, that is equal to new int. What will you pass? N. Okay, what are number of elements? Now you want this in every line, right? You don't want it to be space separated. So we'll run this loop. Say I is equal to 0 and I less than n and I plus plus. Okay, if this is the case, then a of I is basically going to get parsed in every new line. Okay, so you'll do integer dot parse int. It will be br dot read line. Okay, and the brackets or the parenthesis. Now once this is done, next one was your int p, correct? So int p is equal to integer dot parse int br dot read line. Okay, the same thing you will have, but it will just be for q. So I'm just going to copy that, draw copy, and we paste it and just change this to be q. Okay, so it will be q. Next, one thing that you will have is the columns, right? If you want to take that as an input, even if you don't, it is fine. I'll tell you why shortly. So calls will be equal to your integer dot parse int. Okay, br dot read line. So this is the number of columns. This is always going to be two, okay, not true. So once this is done, what are you going to take input as? Your queries, right? So you will do int, and queries are basically two numbers that you're taking with space separation. So queries is equal to new int. What will it be? It will be q and 2. Okay. So this is why I said that we don't have to actually consider in call, but since it's given in the input, I think it's very important that you put it up. Okay. Because you don't know how the input is given, because what they mentioned in the question literally messed up the input format, but thankfully they had given a correct explanation which made sense. Okay, but still, are you going to take input based on your input cases? No, you will take input based on your input format, whatever is given. Okay, got it? So it will be for. Now since you are going to take as many inputs, that number of queries whatever you have entered your queue is, so that is why you need to run this loop. Okay, so I is equal to 0, I less than q, I plus plus. Okay, now within this, what are you going to do? Few things. String. Now this might look little complicated, but this is basically I'm taking a string and I'm calling that parts. Okay, and I'm going to split it. So how will I split it? I'll split it from the space. Okay, because you'll provide space separated input, right? If you remember, it mentioned here that each line contains two space separated integers I and j. Okay, so they'll be space separated. So I'm going to do br.readline dot split, and split how? From a space. Okay, next will be your queries at I0, that will be equal to your integer dot parse int. And what will you parse? You're just going to parse the part 0. Okay, so you'll write in parts at 0. Okay, and so I'm going to copy this entire line because it's going to be the same thing almost. Okay, so I'm going to change this to I1. And what are you going to parse in here? You're going to parse in the index 1. Okay, so once this is done, you come down. Okay, after that, you will just write down your favorite statement, I guess, the universal print statement that we all learn. So print ln, and what are you going to write? You're going to call that function, and you will pass your n, a, p, q, and your queries. Okay, that's it. So now if we go ahead and run this, it was a pretty lengthy code, but that is what it needs. So we are going to follow this exact pattern that we have given. Okay, so let's take in the first input, even though if I don't remember, I'm going to refer back. So it was 4, then it had these 4 elements, so we'll enter 4. Then elements were 9, 12, 15, and 18, right? So we have done with a and n. Next was p, which was 3. So if you remember, p is 3 and q is also 3. Q is also 3, and your number of columns is 2. So what are the queries now? Queries are space separated. So it is 1 9. It is 1 space 9. Then probably 2 space 6. 2 6 and 4 12. Okay. So if you run this, you see your output is 3, and that is what you needed. Output 3. So we are going to try the other two as well. So we are going to keep referring back. We'll run this again. So input is 2. Sorry, n is 2. And what are your array values? 3 and 6, right? So it will be 3, then 6. Then once you're done with that, you have your p. Your p is 3 and your q is 2. So p3, q2, and column then. So that is always 2. And finally, what do you have in your queries? You have 2, 3, 1, 6. So 2, 3, 1, and 6. So that output is 2. So if you see, output is 2. Okay. Similarly, we'll try for the last test case just to make sure that all of them are working. So here your n is probably 3. Yep, n is 3. Your array values are 4, 5, and 6. Your p is 2. Your q is 3. P is 2. Q is 3. And what is your values? Okay, before we forget that, let's enter 2 for the columns. And then we have 3 queries, that is 1, 3, 2, 4, 3, 5. 1, 3, 2, 4, 3, 5. Okay, so the output is 1. So is the output 1? Yes, it is. Okay, so we technically have written a correct code. It is working. You can try your version. Okay, and I hope that you have understood this question. But before that, before we talk about any time complexity or anything, so basically, let's discuss the time complexity before I move on to the Python script. So your time complexity here is basically how much? Big O of n. Okay, and your space complexity, surprisingly, is a constant even after writing such a big code, because we did not store anything, just a couple of integer values. Okay, that's it, nothing else. No, we are not storing anything, so it's technically 1. Okay, so let's go here. I've already written the Python script so that we don't have to write it all over again because it's the same thing. So if you look here, you can directly do GCD, because GCD is a valid function in your Python. So you can just directly call it. You can just import it from the math library, and you don't have to implement GCD like we implemented GCD over here in Java. Okay, so you don't have to do that. You can just call your function get answers, and you can make an helper function which will just figure out the good sequence. Good sequence is this part. Where did it go? Yeah, this part where we are actually checking this list. Okay, so how did we do it here? We just a simple query that for it is x only when x is in a, if x mod of p is equal to 0. It's the same condition. Okay, so if it is not divisible, then return false. Okay, otherwise it is divisible, it will be added into this list. So your good GCD is basically a set of all the divisible. Now for num indivisible, for any number in your divisible, you're just going to update your possible GCDs with this only when GCD is in the when G, sorry, when yeah, G or GCD is in your possible GCD. Okay, now you're going to keep a counter which is going to count the number of yes, and you're going to have I, j in your queries, and a of I minus 1 is equal to j, correct? So that is the formula for assigning your a of I value. Now, has good sequence, you're calling that. If that is true, then you increment your count by 1 and you return your count at the end of the function. Okay, so similarly, n, a, p, q, call, that is always 2, and your queries. Okay, so why have I written this like this? Because we are not taking it space separated. It is one after the other. Okay. So if I go ahead and run this for say anything that we had as an sample set. So I'll choose the smaller one, this one. So your n was 2. Your array elements are 3 and 6. Your p is 3. Your q is probably 2. Yes, your q is 2. Number of calls is always columns is always 2. What are your queries that you have? You have 2, 3, 1, and 6. So 2 space 3, 1 space 6. If you run that, your output is 2, and that is what you want. Your output is 2. Okay. So you can try this code for even all rest of the question, like sample test cases, or even you can implement your own test cases by doing a dry run and see if that works. Okay, and same here, if you can see your time complexity is just going to be big O of n for this one. So I'll just put it down here. Your time complexity is going to be big O of n, and your, oops, I'm so sorry, I'll just pause this, and your space complexity is a constant. Okay, all right, so I hope that you have understood this question. I will see you in the next one. Until then, keep learning, and thank you. Hello everyone, this is Shatrupa, and today we will be looking into another Infosys level question. So it says that the name of the question is basically longest non-decreasing subsequence. Non-decreasing means basically increasing subsequence with XOR problem. Like problem means question. Okay, so just with XOR. So your question is, you are given an array A of length n and an integer m. Okay, a subsequence of A is considered good if it holds true for the following two conditions: that the element of the subsequence are non-decreasing, that means it is in increasing order, and second, the bitwise XOR of these element is at least m. Okay, at least m means greater than equal to m. The XOR value should be greater than equal to m. Okay, so find the length of the longest subsequence. If it is not possible to have any, then choose the answer as 0, or simply if there is nothing like that, return 0. Okay, so you have to define this function get answer. Okay, you're defining this function as get answer, and what are your parameters? You will take an input as n, that is size of the array, integer m, which will be the minimum allowed value for XOR. Okay, and your integer a, all the elements. So first n, then the minimum XOR values and then the elements of array M all the way till n minus 1. Okay. Now, or rather, you can just consider this starting with 1, 2, and all the way till n. Okay. Not n minus 1. Okay. That would be better. So, if you see why that would be better, because your n is starting with 1. Okay. So, similarly, your a of I will start with 1. Now, your input format should be your first line will be an integer n, then integer m, and then all the n lines will be your array elements. Okay. Your output will be just one thing, because what are you returning? You're returning the length of the longest subsequence, right? So let's look into this first example. Okay, so what do you have here as an input? You have n is equal to 2, your m is 1, and a of 1 and a of 2, or whatever you want to consider, 0 and 1, that is completely up to you. So it will be 1, it will be 2. Okay, so this output is 2. What is the output? It is the length of the longest good subsequence. How did they evaluate this? So we'll see it here. So your M is this, and your A is this, right? Now, initially, what do you have? You just have this element, okay? Because you're iterating over this. So you just have, at a given moment, you just have 1, correct? Now, when you just have 1, what is your XOR? Your XOR is 1, and which is true, correct? This is true because you need your XOR is 1. So your XOR should be at least greater than equal to M. M is also given as 1. So this is true. Your length is 1. Now, if you just consider this second element, you don't consider 1, just the 2. So your XOR of 2 is 2, which is again greater than equal to the given M, right? And your length is also 1. Why length is 1? Because just one element. Okay. But now if you consider both of them together, okay, both of them together in the sense that you first itered over 1, then you itered over 2. Now that you are at 2, you're wondering that can you combine these two together and make an array of 1 comma 2? So what will be the XOR? XOR will be of 1. This is the sign for XOR, okay? This is the XOR sign. I know it's looking like a weird logo, but yeah, that that is the XOR sign. So 1 XOR 2 will give you 3. Now 3 is also greater than equal to M, right? So the length of the array over here is 2, that is 1 and 2, right? So the longest good subsequence is 2. So the array itself is also a subsequence. I hope we know that, okay? So that is why your answer is 2, or your output here is 2, got it? So we'll try to understand this. So what is happening is, first suppose you have an array called A equal to 1, 2, 2, right? And your say M is equal to 2. So first we want a non-decreasing thing. Okay, so is this non-decreasing? Yes, it is. Now, XOR should be greater than equal to the given M. Okay, and you have to find the highest number. So the first one, your I will start over here. Okay, so what do you have? You just have this array element, that is 1. So if you do XOR on this, what will be your value? It's 1. And what is the length? Length is also equal to 1. Okay, now you moving this I to this location. Okay, so just 2. Now XOR of 2 is equal to 2, and what is the length? It is still 1. Why? Because it's just 2. But now you want to just combine these two, right? Because you have two elements, you have already seen one before, and now you're seeing at the second one. So you will consider these two, and you will think that can we actually combine it? This is where you will check for the increasing order or non-decreasing order. So you will check, your condition will be that it's 1 less than equal to 2. If this is true, then you can add it. So your new array will be 1 comma 2, right? You added it. So now what will you do? You will do XOR on this. Now if you do XOR on this, your output will be 1 XOR 2 is actually 3. I'm sorry, I think that's 3. Okay, and what is your length? Now your length will increase to length of the array, that is 2 elements, right? Okay, now so far this is the best subsequence that you have got, correct? Because the length is 2, you need to return the longest subsequence. Okay, now moving to the next one, that is this 2, just this 2. If you just consider the last 2, then what is your XOR? Your XOR is 2, and what is your length? Your length is equal to 1, correct? Now what if you add this 2 with this 1? Okay, the last 2 with the first 1. If you do that, what will be your XOR? Your XOR will be 3, and your length will be 2. But we already have found that, right? So there's no difference between this and this. Okay, now you can try one more thing. You can try adding this 2 with this 2, right? but both the numbers are same, so it won't matter if it's increasing or decreasing. It is like less than equal to, so this will satisfy again. So if you figure out what is the XOR of this, whatever the value is, I'm not sure, whatever, say A. So if here your M will be greater than equal to M, but your length, that is still equal to 2. So how do you know which one to choose? You can choose any one of them or you can return all. But what if you decide to add this 2 with the existing this one, 1 and 2? That means what if your array is now 1, comma 2, comma 2. So XOR on this will be equal to 1. Correct? And what is your M? If you remember here, then your M is given as 2, right? So this will not qualify. Okay? But it has the length of, how much is the length? Length is 3, correct? But your XOR will not qualify because your M is equal to 2 and your XOR is 1. So 1 is less than this. It has to be at least greater than equal to 2. Okay? So it will not qualify. So that is why what will be your output for the first, for over here, then what will be your output? Your output will basically be length is equal to 2. Okay? So that is your answer because your maximum length is 2 where it is a proper subsequence and it is good subsequence because it is satisfying the XOR condition as well as the increasing condition. Okay. But here, even though the length is higher than the other three, still your M is not satisfying the condition. Okay. So that is why you won't choose this. Okay. So now let's move on to the code. I hope you have understood this. It's a pretty simple question. It's just that they have complicated the entire thing by writing a huge story on that question. Okay. So let's reconnect this and we'll start writing this. Say define get answer. Okay. And we'll pass n comma m comma a. Okay. Now we are going to use dynamic programming in the bottom up approach. So we'll create a DP. And what will be the DP initialized to? Initialized with all zeros for, say, suppose 1024. I guess that was what was mentioned. Okay, so it has 1000, but we'll say we'll take it for 1024. Okay, so once this is done, once you have initialized your DP, so for will run in the range. What will be the range here? So the range will be n, correct? Whatever the n that you have entered. Now it's time to fill up our dynamic list that we created here over here. It is called DP. So what will you do? Say for I in your range of n. That is how your loop will run, right? So you're going to say your DP at I. Okay, now this is interesting. A of I. Okay. I guess this should be like this. Okay, so once this means that element is just one single value. Okay, if that is equal to just one number, if the element is just one, right? Like here we considered just one. First it was just one, then again one, then we combined it. Okay, like that, just one. Then what will you do? You're going to run another loop j in the range of I. Okay, and here you are going to compare if it is in non-decreasing order or not. I'm sorry about the bad typo that I have at times. So it's going to be if I of j is less than equal to a of I. If it is a non-decreasing thing, then you will enter the loop and you will start doing the further part, that is x in the range of, say, 1024. That is what we have taken. Okay, and what will you do in this range? You're going to evaluate if your DP at j and x, DP at jx is basically greater than 0. Okay, then you're going to have a new x, let's call that, and you will do your XOR. Okay, these have to be positive numbers. Why? Because it is starting at 1. If you remember the given condition over here, it starts at, all starts at 1. Okay, you will do the XOR on a of I. Okay, and then your DP will basically have I and new x, correct? New x, I'm sorry. So what will this value be? This will be basically the max of two things. First will be your DP at x, sorry, at I and new x, or what's happening today? Or it will be DP at jx plus 1. Okay, so Once you are done with this, now you will have something for the best results of x or greater than your m, right? Greater than equal to m. So we'll basically have answer. I'm sorry. So this is if, this is for, if, for. Correct. So we'll have answer is equal to 0, and you will run this as for I in the range of n again. Now, once you are done with this part, what are you going to actually do? You're basically going to append the value into your answer, right? The best one. So, where do you have to iterate? You have to iterate in x, right? So, you will iterate in x, but what will be your range? Your range will be m all the way till 1024. Why m? Because it is at least m, right? Greater than equal to m. So, equal to m. So, it should start from m, and your answer will be basically the max of either the answer a and S or your dp of ix, dp at ix. Okay. And what are you going to return? You are going to return the answer. Correct. Now, once this is done, you are going to write the main function, right? Where your code will actually start executing. So, suppose you have name, and that is say equal to your this. Uh, okay, we are not considering this part. Okay, for now. Or we can, that is completely up to you. So, technically, yeah, we had to take those three inputs. Okay, we had to take those three inputs like n, m, and a, but a we don't know what the range should be. So what we'll do, we'll just do it in a little different way for a. Okay, so we'll not take this kind of input. Now how will we do it for a? Now this is basically a. We'll initialize this, and we'll write that for I in range of n, we have to append it. Okay, so make sure you append properly. So we'll do a dot append. Here we will take the input. Okay, we can take this as the input, but we'll do one more thing, that we will use strip to just make sure that we have the correct answer. Okay, so finally we'll not do this print, but what are we going to do? We are going to run result, and what are we going to call? We'll do result is equal to get answer, and get answer what? N comma m comma a, right? That is it. Okay, so that is all that you will do. I'll just add one thing here for convenience. So suppose we have print, and we say enter. Let's put this up so you can differentiate between the array elements and the input. And array elements. Okay, let's do this. Okay, I missed out one thing, that is equal. Okay, so we'll run this now. Okay, so we are going to enter the value. So I don't remember what it was. So that was n is 2, m is 1. So we'll go 2, m is 1, and then you have this. So you have 1 and probably 2. Yep, and your output should be 2. 1, 2, and your output is oh, okay, I didn't print it, right? Yeah, my bad. So we are just going to do print, and what are we going to print? Just the result. Okay, so let's run this again. So we have 2, then 1 as an m, then your array element, and so your output is 2. Got it? So again, if we run this for the remaining of the examples that we have, that is 2 and everything is 1. So number of element is 2, m is 1, array element is 1 and 1. So your output is 1, right? For the last test case, your input is 4, then 3 is your m, then you have 4 elements, that is 1, 2, 3, and 4. Your output should be 4, right? So that is what you have here. Okay, so talking about your time and space complexity, this is something that I want you guys to figure out. What will be your time and space complexity? Is definitely not m times n. It was written from the previous code, but yeah, it's not m times n. So just try analyzing what your thing will be, because you have not used anything other than your bottom up approach. Okay, so this is a dynamic programming code. It can be m times m as well, because we do have a grid, proper grid. So but still I want you to think about this. Okay, so moving on to the Java code, but just in heads up, in the Java code I have already written the code because it's the same thing. So you will just make sure that you have the code exactly in order like this, or if you have your better code than this, go for it. No hard rule that you have to follow my code, but I hope that you've just understood what it is trying to do. Okay, so Java, import java.util, your class is made. Now again, this is an online Java compiler, so if you have your own, you can change your class name to anything on your IDE that you use. Okay, so you're going to get answers as the function name, because that's what is mentioned in the question. You will take input as n, m, and a. Okay, so this is your longest subsequence ending at I with XOR value x. Okay, so what are you creating? You're creating basically a list. Okay, and this is how you're going to do it. Okay, so it's almost same. So once you created that list, you will iterate through the values, and you will see if it is just equal to one value, just the element, like 1 or 2, like we saw while solving here, like 1 or 2. Then what are you going to do? You're going to run another loop J, where you're going to compare if it is in increasing order or not. Okay, and it is the same code as we saw in Python. The only difference is here you can actually do math. Okay, use math for the XOR thing. You can do math in Python as well, but I guess you need to check for the exact class that it is using. Okay, so you can do this for XOR thing I spoke about in the Python case, but here the math is being used for maximum, to figure out the max. Okay, then once you're done with that, you need to find the best solution for XOR, which one is satisfying this condition where XOR is greater than equal to M. So again, you will initialize an answer variable and you will run a for loop for this range, and then you're just going to find out if the answer is greater or the value that you just got is greater. Okay, and accordingly just append it to the answer. Finally, you just have your print or the scanner class, like where you take the input. So scanner equal to new scanner, and you just take n as your input as in the array size, the minimum allowed value for m or XOR, and then you have your array that you have created. So you iterate over it and you take input, and finally in your result, call that get answer function, pass these three values that you have just taken the input, and print your result. Okay, so if we go ahead and run this, it's wrong. So if we run this, no, I want to run this. Okay, something's just off with this. So I'm just going to copy this code again and just reload this page. Copy and reload. Okay, so I am going to run this. Yep, now it's working. So suppose we use the first example, that was your n is 2 and your m is 1 and your array elements are 1 and 2, then your output will be 2. Okay, so if you see your, this is your output. Okay, that is the end of your input, this is the input, and the last 2 is your output. So if we run this again, say we enter 4, 3 as in your m, and then you have your 4 array elements, that is 1, 2, 3, and 4. This is the last sample test case that we had seen, that so your output is 4. Okay, so if you run this again, and let's do it for the second test sample case that we had. So n is 2, m is 1, and 2 array elements was 1 and 1, so your answer was 1. Okay, so I hope you have understood this question. I will see you in the next one. Until then, keep learning and thank you. Hello everyone. Today we will be looking into another Infosys hard level question. So it's not that hard if you understand the logic. I know there's a lot of writing they do in the question, but we'll try to simplify as much as we can. Okay, so this is basically the sorry, let me use no pen. So yeah, it's basically tree edge flipping with pattern matching problem. So the question says that you are given a rooted tree with n nodes labeled 0 to n minus 1. The root is 0. Each node has a binary value that is either 0 or 1. The array parent of I defines the tree structure starting with parent of 0, where I should always be greater than 0. Okay, so parent I is the parent of the node I. You may flip a set of parent child edges such that no two flipped edges share a node. Okay, the flipped edges form a matching. Flipping an edge toggles both the endpoint. Okay, that means both the values will change. 0 will become 1, 1 will become 0. Okay, and the cost of m coins. So there will be a cost that will be given. So each edge can be flipped at most once. Any edge. If you are flipping 0, 1, 4 if this is the order. You can, if you're flipping this to, then you can do it only once throughout the code. Okay. For binary string q, a root to leaf path is natural if after the flip its node value contains q, as in a contiguous substring. So q will basically be the queries that you will pass on. So for each q queries, binary strings that will be, you must do the following. Choose any valid flips to maximize the number of natural root to leaf path, or amongst all choices with maximum natural path, pick the one with minimum total. Okay. So your cost is basically calculated as m, whatever amount will be given, into or multiplied with the number of flipped edges. Okay. So you need to find the sum of the minimum cost all over the queries. Okay. So again, you have to write the get answer function, and it is going to have n, that is number of nodes, m, that is cost per flipped edges, and there will be a parent tree. So you need to write the array, all the node value, and there will be a value array where you have to provide the binary values. There will be q, that will be the number of queries that you want to enter, and then you are going to enter the queries, okay, whatever you have given, and you'll finally return an integer which will be the sum of minimum cost of all the queries. Okay. So the input format has already been given over here, and that is what we discussed over here. Okay, it's the same, the parameters and the input thing. So you're taking an n first, then an m. So n is the number of like nodes that it will have. This is the cost. This is the node, and then it will contain the parent nodes. Okay, and this will be the value that will either be binary, so 0 or 1. And then the next line will contain your number of q queries, and then it will have the queries. Okay, and that is your output. That's a single integer. Now, so there's an input given for you over here that you have 6 nodes in total. This is your n, this is your cost m. Now 1, 2, 3, 4. Okay, I get it, 4 and 5. So these are your parent node, p of i's. Okay. Next, you have, so is this 6? Yes, this is 6. 1, 2, 3, 4, 5, 6. Okay. What does this mean? That it means this is 0, like it will have a 0, then 0 and 1. Then with your 0, you will have two more, 0 and 1, and here you will have one more. Okay. So like that. You need, I will explain this later when we draw the tree. Okay. And then you have your values, that is 1, 0, 1, 0, 0, and 0. So this is your val of I, all the binary. Then you are going to enter your two queries. Now this is query of 1 and this is query 2. Okay, these are all binary strings. Okay. Now for the given thing, if you understand 6 nodes, 0, you have then 0 again, then you have 1, correct? Now at 0, what do you have? You have 1 and 0, and you have 0. Okay. So this is the value if you see. So this is your node 0. This is your first node. So, okay, I'm going to just do make it more easy for you. Okay. Now each node has a value assigned with it. Okay, each node has a value assigned with it, and this is the root. Okay. Now look at the paths. Suppose this path. So 0, 1, 3. What is the value for this? 1, 0, 1. Okay. So the value for this path is 1, 0, 1. Okay. Now let's look into the next path. This, this, oh, sorry, not this, this. Okay. We did this. Now we'll do for this. So it will be 0, 1, 4. Okay. What is the value? It is 1, 0, 0. 1, 0, 0. Okay. Now last we have one path, that is this. Okay. So it is 0, 2, 5. What is the value? It is 1, 1, 0. Correct? Now, your goal is to basically see that if you have these queries in the string or not. That is your goal. Okay. Now, if you want to actually validate the query 1, that is 10, okay? So we'll start with this one. So over here, if you see, you already have that, right? You already have this, correct? So here, how many flips? Zero flips, because it is already existing. Similarly, for here also, you already have it here, correct? So again, how many flips did you do for this one? This was also zero flip, okay? Now, if you come over here to this path, do you have that 10? Yes, you do. You have it here, right? So how many flips? Zero flip. So for query 1, what is your cost? It is zero flip times m, that is 3. M is given as 3 if you remember right here. Okay, so that is equal to 0. So total cost for query 1 is 0. Okay, now let's look into query 2. What is your query 2? Your query 2 is basically this. Okay, so I'm going to just erase all of these values so we can solve this. So, okay, so I'm going to rewrite all this again. So the first path was 101, next one was 100, then it was 110. Like not 110, but yeah, I'm just talking about the binary values. Okay, so now what is your query? It is 011. Okay, let's look here. Do you naturally have 011? You don't. Okay, so what you need to do, so in path, in this path, so you have to change this. How will you change? What if you already have this last position matching, right? You already have this last position matching as in 1. Okay, so if you just flip these two, it will match, right? So you have this, but you already have this matching. So if you just flip this node, okay, so that means your value 1 will become 0 and your value 0 will become 1. If you do that one flip, are you getting this? Are you getting this value matched? This is 11011 now. Is this same? Yes, it is. So how many flips did you do for this one? You did one flip. Okay, so we'll remove this now. Fair enough. Now let's go to the next path, that is this. Okay, so it has 100. Okay, so if you do one flip, okay, if you flip these two, okay, if you flip these two, what will be your value if you are just looking at this index, this path 124? So if you flip these two, it will be like all zeros will change to 1, right? Flipping means goes to the reverse, correct? So what is the value now? It is 111, correct? Is 111 matching with this? No, it's not matching, right? For this, you need to do one more flip. Okay. So if you try flipping these two now, will that be allowed? Why? Why is this my question? Because over here in the description, it already said that each node can be flipped at most once, maximum one time, correct? And if you remember, you have already flipped 0 and 1 in this just to get it aligned. Okay. So for this one, how many flips you are requiring? You're requiring max two flips at least to get this converted into 011, right? So this is not working, so this didn't work. This path worked, this did not work. Now let's look for the last one. Okay, so you have 0 to 5, correct? You have 0 to 5. Now let's consider 2 5. Okay, can we flip that 2 5 because we need 1 at the end, correct? So you have 2 5. So what is the value of this one? It is 110. So if you flip the last two, these two, so this will become 1, this will become 0, right? Again, if you flip, if you're flipping 0 2, okay, now 0 2 is unused. So if you flip 0 2, okay, what will this become? This will become 0 and this will become 1, correct? You are getting it, but after how many flips? After two flips, okay? So the question says that you have to figure out the maximum, right? So in this query 011, what is the minimum number of time, at least number of times that you need to complete all the three parts? At least you need two. Okay, at least two flips to complete all the parts. Okay, so since it needs at least two, so for your query 2, your value will be 2 into m, that is 3. Answer should be 6. So if you go down, yes, your answer is 6. If you see the explanation as well. So it says for this, look at path this. So it already contains that. Okay. So it does not require anything, zero flips. But for this one, in your current labeling, no path contains this. So by flipping in up to two subtrees. Okay. First subtree was this, the next subtree was this, the last one. Okay. And minimum flips being two. Okay, minimum flips being 2, your total cost will be 2 times 3. So what will be your total cost? It will be 0 from query 1 and 6 from query 2. That will give you 6. Okay. So similarly, you have output test case 2 and test case 3. Okay. So before we go into evaluating this, we'll evaluate these in the code itself, and we'll not do it here. We'll not try run this. So let me just tell you that we are going to write this code in two languages. That will be Java and Python. So we'll start with the Java one and then we'll go to the Python one. I'm not going to code the Python one. I'll be coding the Java one for this question. So Python one, we'll have the code ready and we'll just go through it. Okay. Sounds good. Sounds like a plan. I know people have been asking about why not C++. See, it's not possible to put in all the code in this one session. It's going to get too lengthy and unnecessary because the logic remains the same. If you understand the logic, you can code it in any given language. But still, if you want the solution, let me know in the comment section. So maybe I'll just generate a PDF and send it to you people, right? Uh, Other than that, I don't have anything else to do for this session. Okay, so let's get coding. I'm going to code this in the GDB compiler. That's an online compiler. So I'm going to not name my class anything. So if you have your own IDE, just name it whatever you want to. Okay, so it will start with import Java, and I won't name my class anything. By this, I mean that it already has a name because this is an online compiler. It has a name of main already, and I'm not going to change that because it won't run my code. Okay, so if you're using your local IDE, just go ahead and name whatever you want to name the class. Okay, so we'll take in three integers that will be n, m, and q. Okay, now next will be your array that will basically be your parent, and let's make this capital just in order to be sure, and val. Okay, and before I proceed further, just an heads up, it's going to be a little lengthy code, so bear with me. If you have an easier solution, which I definitely know we have, so I want you guys to code that. I'm going to just show you the normal layman process. I'm not writing an absolutely optimized code. Okay, this code can be further optimized, like in terms of length, because the code that will run, it will be in time complexity of O of n. So I think it is pretty optimized, but I'm talking about the number of lines that we have in this code. So I highly recommend that you can reduce the length, write a better code. Okay, so next will be the queries, the list of the queries. So we'll call that as a string because we are entering binary strings, and we call it queries. Okay, and that will be a new array list, and that's it. Okay, so now I am going to copy this because we are going to repeat the same thing for the tree and for all the path. Okay, we'll just rename this. Rename this to tree, and okay, and this one to say all paths. Okay, now once this is done, you have to define your main function. So we'll take in as public static void and main, and definitely what do you need to take is your string arguments. So string arguments, and let's start the main part of the code. Okay, so here I'm going to first take all the inputs. Okay, so if you want, you can leave this blank, you can go ahead and code this first and then, but I'll just do it quickly. So scanner class, you're going to do new scanner system dot in, correct? Okay, and once this is done, you're going to take your input as an n is equal to scanner dot next int. So what is your n? That is the number of nodes, correct? Then your m is also equal to your scanner dot next int. What is your m? That is the cost. Okay, and then you have your parent, so you're going to enter that as an array, right? So that will be int n, and the next one that you have is the val or the value, so that will also be an array. So you will have that as n as well. Okay. Now we are going to take them in a single lines, just how it was shown in the input here. Okay, like this, one after the other. So what are we going to do? We are basically going to run a for loop, say for int of I equal to 0. Okay, I less than your n, definitely, and I plus plus. Okay, and this will basically append to your parent of I. Okay, and how will you do that? Do that as scan or se dot next int. Okay, so just copy the same line for our values as well. Just paste it, and it is the same thing. Instead of parent, it will just change to values. Okay, so once this is done, what else do we have? We have for our tree. Now what will we do? We'll do the same thing. So let me just paste this, but not this anymore. So we are going to just do tree dot add. What are we adding? We are going to add the new array list. Okay, so yeah. Now, after this is done, we need to get these nodes from the parent, right? So how will we do it? We'll do it like this for, okay, let me just add this, and I'm just going to edit that only. Okay, so we'll do something like this. Make sure you start your node at 1. Your node can't start at 0 anymore. Now you'll have tree dot get. Get what? The parent thing, right? So the parent of I dot add I. Okay, so once this is done, you come out of this loop, and you're going to just code for the queue now. Now, what is your queue? Your queue is the number of queries. So you will do sc dot next int. Okay. And then you will do se dot next line. Okay. Very important, next line. And what do you enter in the next line? Again, this will basically be the queries that you will take input as. So it will be for same I equal to 0 and I less than your q. It should not be greater than that. So it should be less than your q and I plus plus. Okay. Now inside this, you're just going to append queries dot add, and add what? Whatever queries you have. So every query should go into a new line in order to not get confused. So you just use the trim function. Okay. And that's it. Now once this is done, we are going to build another thing, that is all paths. So we'll name this as get all paths maybe. Okay, and this will start at 0. And what will it be? It will be basically the array list. Okay, so once you have done with this, now what are you going to do? You're basically counting the total cost, which will basically be in your get answer code. Okay, that is going to be calling the get answer. So finally, you will just do system dot out dot print ln. What are you going to print? You're going to print your total cost. Okay, that's it. End of the function. Okay, now once you have come out of this function, so you're going to go one step outside this, and what are you going to write basically? So this should basically be here. Yeah, you're going to start a new function, that is get all paths. Okay, now get all paths will basically find out all the paths starting from the node. Okay, so you're going to define that, say static void get all paths. Okay, and int, say node, and list, what will it be? It will be integer, and we call that path. Okay, next, what are you going to put inside this? So you will do path dot add, and add the node. So if your tree dot get node is empty, okay, if it is an empty thing, then what are you going to do? you will simply do all paths dot add, where you will be using that array list of path. Okay. Now once this is done, you're going to do else. In the else, what will you do? You will write a for loop. Say for every child node. Okay. The tree must get its node. Okay. What are you going to put in this now? You're going to call that get all path function, like the path itself. So, and you're going to pass the child and the path. Okay. Now you come out of the loop, you come out of the else, and then you're going to remove that path and just decrement it by 1 because you're going back. Like over here, if you remember, we came 0, 1, 3, and then we have to remove 3 to go back to 1 and go 4. Okay. So that is exactly what we'll do. So we'll do remove path dot size 1. Okay. And we are done with this function. So you are going to basically do two more things. That is writing the main function that was asked to be written, that was the static long get answer. Correct? So we have a long total cost. Okay. And then we are going to start coding that. So how do we code this? We'll be given some queries, right? Some query strings, or like the queries that we have to execute. So we'll do that for your string query. There is queries. Okay. The main thing that we have. Okay. For every pair of that, you're going to do q length, which will be equal to your query dot length function. Okay. So we need to figure out what length it is. Next, we'll have say int max natural. That means if naturally there is something, some query that is matching. So we'll set that to 0. And int, we'll have a min cost as well. Okay, that will be basically integer dot max value. Why max value? Because we need the max number of times that we can actually we need the max value, right? So that is our minimum cost. So if you have seen that we chose a number 2 over here, but yeah, that wasn't the minimum amongst all of these. That was the maximum of all of these. Why? Because that is the minimum number of times in which we can actually finish all the parts. Okay. So that is why it is max value. Okay. So once this is done, you will have your limit. Now, the limit is for basically number of flip combinations. So you need to just track that. So I'm going to just take limit will be equal to, we'll do math dot min. Okay. So now you're going to just run this for int say mask is equal to 0 and your mask is less than say 1. You're just going to do the shift operation on the limit. Okay. And just increment your mask. Okay. Next, you're going to just set your integer. So let's make this like affected. So the number of things that you're going to flip into a new hash set. Why is this a set? Because you want the unique path. You don't want the like already affected paths. Okay. So int flip count, maybe that will be equal to 0 initially. Okay. So now for okay, one thing before we actually set this flip count to being 0, what will we do? We'll basically consider that there is a loop that is going to run int of I is equal to 1 and your I is less than the limit, and then we are just going to do I plus plus. Okay. Now, if the mask and your I, sorry, actually 1 on the shift operator of I is not equal to 0, then what will be it doing? It will basically do flipped dot add I. Okay. So this is the end of your for, and now when you come out, you're going to do boolean valid or not. If it is valid, then set that to true, and then do a set integer. Actually, why did I call this affected? This should be flipped. Okay, and now here we will initialize the affected one, integer affected. Okay, and that will basically be your new hash set. Okay, here you will have your flip count to be set to 0. Flip count is equal to 0, and now you're going to run another loop. Okay, so this code is going to get much bigger and bigger. So what I'm going to do for you is, I already have this code written. I'm going to just change that thing, and we are just going to copy paste that code. Okay, so I have copy pasted this part. So in order to just avoid any kind of issue, I have also provided the indentation or the comments where you know what exactly is being done. So we were right here. Okay, so once you flip the node, so you're just going to compare if the node is flipped or not, and if that is the case, if it is not affected, then you will return false and break. Okay, otherwise you're just going to add that thing to the parent node, and you're going to continue flipping it. Okay, increment the flip value. Okay, if it is not valid, then continue. Okay, now you have to apply the flips. How will you do that? It is going to be the new val. You have to use the clone function. Okay, so new val will basically have all the values that you had used earlier. Okay, so now node to the flipped. So parent node is basically being set to this variable parent. Okay, now you're going to count the number of natural paths in this. Okay, how many paths that you did weren't flipped. Okay, now the best way to do this could basically be if you update your natural. You just do the comparison continuously. If your natural count is greater than your max count, then your max natural is equal to your natural count. Okay, and what will be your min cost? Your min cost will be number of flips times the m, or the cost that was given. Okay, and then you just need to find out what is the min. Okay, and then run for your total cost and return your total cost. Okay, so one thing that I will show you is, I had run this on my IDE, so this was the name, but for this one I'm going to change it to main. Okay, and let's run this. So as far as I remember, it was, yes, got it. So the first one was 6, then m was 3, then the nodes that we had were 0, 0, 0, 1, 1, and 2. Okay, the values that we had were probably 1 1 1 0 1 1 0 0. Okay, 1 0 1 1 0 0. Number of queries were 2. We had 10 and 0, sorry, 0 1 1. So the output is 6. Okay, so if we run this again for the next set of values that we have, that is 4 3 4 3, that is the cost. So the number of nodes are 4. The parent node is 0 0 1 1, 0 0 1, and 1, and your values are all 0. Values are all 0. Then you have two queries, that is 10 and binary 3. Okay, so if we hit enter, that should be 6. Is that your 6? Yes, that is your 6. Okay, similarly, if you run for this output, it will give you 3. Okay, now we'll see the Python code. So it's the same thing. Okay, just that I have used a default dict instead of doing it randomly. So you can go ahead and do that. So you will assign your children things to a default dictionary, and then you will do get all paths. Okay, same like the Java code. You will get all your paths and assign your total cost to be 0. Okay, now for the query in queries, you're going to do this. Now this is the pattern longer than the path. Okay, so if that's the case, then just continue. Otherwise, your min cost will be set to infinity. Okay, and your max number of flips. So we're just putting a limit. Like in Java, we took 15. So this limit is basically for your traceability. Okay, you're able to trace it. Maximum number of flips. You won't need that many flips. Okay, so for the mask in the range of this, we are determining which edges are to be flipped on basis of the mask. Okay, and so we continue flipping. So check if the flipped edges form a valid matching. If it is matching, then fair enough. If not, just keep continuing, okay, to see if anything happens. But if at any point you find a false, just break out of that, okay. Now after the new values, you need to just count the calculate the flips, okay, and also check if there is a natural path in the given query or the given path or not, okay. Then finally, what will you do? You just have to join it in order to just check if there is a natural thing or not, okay. And yeah, that's it. You just, this one is for the updating the result, that is your total cost, okay. So let's run this. So here we'll run for the last sample case that we had, that was 5 and 3, 5 as in the node, 3 as in the cost, and whatever the values, 0 0 1 1 2, 0 0 1 1 and 2, so 5 nodes. And what was the value? It was 0 1 0 1 0, 0 1 0 1 0. Number of queries is again 2, and what are the queries? 0 1 and 10, 0 1 and 10. So if we go down, the output is 3. Okay, so the output is 3. All right, so I hope you have understood this question. I would really appreciate you guys writing a smaller code. This was a pretty big code and inefficient in terms of explanation, readability, and everything. I know that I did that on purpose. I want you to write a better code, but understand this is an optimized code. It's not bad at the time complexity or space complexity. But yeah, the length and the way it is written, it is a little complicated. So I want you to write a better code. All right. So with this, we come to the end of the video. I will see you in the next one. Until then, thank you and keep learning.